Assalamu alaikum everyone. So we are going to start. Basically, we're going to continue the previous topic, that was the homogeneity equation. In today's video, we will see how we can use homogeneity. Okay. So homogeneous equations or the homogeneous analysis can be used for the different purposes. Okay, from one of one of the purposes, you can check the formula or the relation that it is correct or not. The second is you can find the unit of unknown. And the third purpose is you can find the unknown powers. Okay, we will see all of them one by one. So first of all, we are going to see its first use homogeneity to find units of unknown quantity. Okay, let's discuss with example of, let's suppose we have some relation that t is equals to 2 pi square root I over mgh. Okay, let's define what they are. T is the time. Okay, m is the mass, g is acceleration, and h is the length. What we have to do, we have to find units. Basically, it's find base units of I. What I is, we don't know. So how we can solve this? We have this basic equation. Let's write it down again. I'm going to copy paste it here, make a duplicate. Okay, so let's apply the unit analysis. For time, we know it's second. This 2 pi will not have any units, and there's a, let's write it as the power of 1 over 2. Let's write the I as it is, because that is the thing that we have to find. Okay, for m here comes kg, for g here comes ms minus 2, and for h let's write it as m. Okay, so it will be s is equals to I over kg. There are 1m is here, 1m is here, so it will be m square s minus 2 whole power 1 by 2. Okay, there are different methods to solve from there. What we can do, we can take square on both sides. So if I take square on both sides, this square will be cancelled out with the square root, so it will give you s is equals to I over kg, this is square, meter square per second square. So this thing that is divided here will go there, and it will be multiplied. So I will be equals to kg meter square per second square, and this is already there. So if you see, this power is plus 2, this is minus 2, so that will cancel out. So I can be written as kg meter square, right? So these are the units of I. Okay, the unknown. Okay, let's discuss another example of the same type. Let's suppose the equation is m over t is equals to kc under the root rho into p. Let's define what they are. M is mass, t is time, k is some constant without units. Okay, There are two types of constants. Some constants are with units and some are without units. So this case without units. P is pressure and rho, the Greek symbol, is used for density. Okay. What we have to do, find base units for C. Okay, let's try this one with a different method. Okay, so what we can do, in mathematical term it's called making subject. So we have to find units of this thing, right? C. So we can make C the subject first and then we can simplify it. Okay, so both methods are equally right. Whatever suits you, you can do it. So C is equals to this thing is multiplied here, they will go on the left side and they will be divided. So C can be written as m divided by t is already there, so there come k and under root p into rho. Okay, so we have to put the units. C is equals to, C is unknown, so you don't have to write down anything. For mass it is kg. For time it is second. K does not have any units. Okay, so under root P and rho. So P was the pressure. If you remember, pressure is force over area. So it is kg meter per second square divided by meter square. It is kg m minus 1. Okay, it's a quick review. Density is mass per unit volume. So it is kg per meter cube. Okay, let's put these here. So dense pressure is kg m minus 1 s minus 2 and rho is kg m minus 3 and whole power 1 by 2. Okay, so let's simplify this thing. It will be kg s, and when you open the brackets, okay, let's don't open the bracket right now. It's kg, it will be kg square, and this is minus 1, this is minus 3, to m power minus 4 and s power minus 2. Okay, and the whole power is 1 by 2. So when you open this thing, this 1 by 2 will be divided. Let me write it down. It will be divided here, here and here. Okay, so it will give us kg s kg m minus 2 s minus 1. Okay, and now this can be cancelled out, and this s and s will also be cancelled out, and when this thing will go on the numerator, it will be meter square. So these are the units of C. Okay, let's discuss with the help of the next example, example 3. Let's suppose we have a relation f is equals to 1 over 2 c density a v square. Let's define them. F is force, a is area, rho is the density, v is the speed. What we have to do, we have to show that C does not have any unit. Okay, so if we have to show that, we can follow the same steps that we have done. We can make the C as the subject, so it will be C is equals to 2f divided by rho a v square. It can be rearranged like this. Okay, so let's apply the unit analysis. C is equals to 2 will not have any unit. For f it is kg meter per second square. For density it will be kg per meter cube. For area it will be meter square. For velocity it will be meter per second, and there is a power 2 on it. Okay, so let's simplify the denominator. Numerator will come as it is. So there is only 1 kg, it will come here. If we see the meters, it's meter cube power 2, and sorry, this is also power 2, right? Because there is a square on it. So power 2 plus 2, 4, and minus 3 is m power 1 and s power minus 2. It will remain like this. So this s power minus 2, s power minus 2 will be cancelled out, kg will be cancelled out with kg, and this m will be cancelled out with m. So this will give you c. So it has no units. We have proved this. Okay. So this is how you can find the units of any unknown, right? In the next video, we will discuss how we can find the powers through the homogeneity of the equation. Okay.